Real estate investment practice problem using Excel. Incremental borrowing costs. Get ready because we're raising the stakes with real estate. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we have 3 tabs down below. We got the example tab, the practice tab, the blank tab. Let's take a look at them now, starting with the example tab, in essence being an answer key, comparing 2 loans, 2 30-year fixed loans, one with a larger loan amount than the other, and having a larger rate as well than the other loan, looking at the incremental borrowing costs of going from a $120,000 loan to the $135,000 loan. When looking at these 2 scenarios, you might say, well, the cost is the increase in the rate, which would be the 5% increase. Or you could look at the payment and say, well, the payment's going to be increased by this amount over the $880.52. Those are 2 good things to take a look at. But we also want to consider the incremental borrowing costs in terms of a rate as well, noting that as we increase or add more debt, then the incremental rate will increase as well. So that's what we're going to be considering this time as another tool that we could take a look at. So we got our 2 amortization tables. Then we're going to be calculating the incremental borrowing cost. And then we'll be thinking about, well, what would happen then if we were planning to sell in 8 years? Does that have an impact on the incremental borrowing costs? And we'll also calculate that same incremental borrowing cost using the IRR calculation, as well as a rate calculation, which I think the IRR is a little bit more intuitive. All right, so if we go down to the practice tab, that has some pre-formatted worksheets, so you can work through this practice problem along with us with a little bit less formatting. And then if we go on over to the blank tab, that's the one that we work from scratch. This is the scratch that we have. We scratched this one out for you, and then we're going to be building on from there. So first thing, we got the first loan, which is $150,000. We got the 10%, the $15,000 down payment. So we're really focusing here at this point, the $135,000 loan, the 30-year, $360, the initial rate, or this is going to be just called the rate. Let's say the rate's going to be 8.5%, and then the payment calculation using the payment function 1,038.03, calculating our amortization table. It will then populate all the way down. It should be fully amortized at the end of the 360 periods. Looks good. Everything looks correct. Going to copy this over and then do our adjustments to it for a loan with where we have basically the 20% down instead of the 10. So if I'm going to say, let's copy from A on over to I. AI. This is the AI. I'm not AI. I'm an actual person. But we're copying from A to I. And then we're going to say V, Control V, paste that on down. Then we'll make our changes. We're going to change the down payment from 10% to 20%. So we're saying we're going to put 20% down, $30,000. That's going to make the loan go down to $120,000. Still a 30-year, 360 months. But the rate now is also going to go down to 8% if that were the case. The payment calculation, then recalculating our data, now calculating at the 880.52. Once we have that, then we want to repopulate that into our amortization table, the amort table. And so I'm going to then recalculate that. I thought that would go smaller, but it didn't. Whatever. Payment. This payment needs to be that payment. Now, this is absolute. That's why it's wrong. So I'm going to delete that reference right there. Point to the 880.52. F4 keyboard, $ before L and 17. Enter. Put our cursor back on it. See the little fill handle button. And double click on that, bringing it on down. Interest rate, same thing, same problem. That's going to the prior data because it's absolute. Removing it. Now picking up the new 8% right there. F4 keyboard, absolute reference, $ before L7, and enter. Putting our cursor back on it, double clicking the fill handle, bringing that on down. Let's double check all the way to the bottom. Put 2 checks by this to make sure that things have been done properly, seeing that we're at 0 and that the loan has been fully amortized. There it is. It looks like that's things are going the way they're supposed to happen there. So that's good. So now we're going to calculate the incremental borrowing. So notice if you're looking between these two, we're going to say, well, is it worth it for me to put 10% down or 20% down? Should I borrow the other 15? Obviously, you'd be saying, well, I'm concerned with the payment amount. Can I make the payment amount? That's important. I'm concerned with the lower interest rate. But what's the incremental rate between the two, the incremental borrowing rate of borrowing that other 15,000 if I possibly don't need to, if I can basically go between the two of them, for example. So let's do that. Remember that the cost kind of goes up with the loan as you borrow more. So even though the rate, so the incremental cost, the incremental borrowing costs will be higher. So we're going to say the incremental borrowing cost, and let's make this one a little wider, like so, just like so. And then we'll copy these and say this is going to be font group, and it's going to be white or black and white. And then we're going to say the difference, we'll take the difference in the two borrowing amounts. That's important. The difference in borrowing amount, borrowing. And we're going to say the larger loan amount was equal to, that's the one all the way to the left. I'm going to say equals. I'm going to pull that 135,000 there. And then versus the smaller loan, which I'm going to say is equal to the 120. Put an underline there, font group and underline for formatting's sake. And then we'll take, this is going to be the difference in it's still spelled wrong. I'll do a spell check. Borrowing. Oh my goodness. This will be equal to the 135 minus the 120. Could you fix my spell in Excel? Would you? Por favor. Okay, they might have put a wrong word in there, but they say it's good now. So I'm going to then say alignment indent, indent it again. And then we're going to have the difference. Oh, here we go again. Maybe I should choose another word that I can spell. And this is going to be the larger loan and the smaller loan. So the larger loan had a payment amount, which is equal to, if we took the larger loan, we got to pay more because it's a bigger loan. The 1,038, and the smaller loan had a payment amount monthly of the 880.52. So there's a difference in payments of equals the 1,038 minus the 881. That's going to be the 158. Let's add some decimals. Number group, adding decimals, underline under the 880, font group and underline. Let's do some indentation. We're going to go to the home tab, alignment, indent, and indent this one again. And then we're going to say, you would think we'd do some kind of subtraction problem here, but no, we're going to do like a rate, now that we have all our tools, rate function calculation here. So this is going to be equal to the rate brackets, and we're picking up the number of periods. The number of periods is going to be the 360, the full amount of the loan, 30 times 12 as normal. The payment amount is going to be the difference in the payments that we're looking at, which is going to be this one right above that we calculated in W6, comma, the present value. The present value is going to be the 15,000 up top, and I believe we need to make the payment negative to make this work properly. Closing it up, and let's go ahead and add some decimals. Adding decimals, that would be for a monthly rate. Let's take that whole thing, double clicking on it, and multiply it times 12 to get the yearly. So we're at the 12.279 about. So the incremental borrowing rate for borrowing the extra 15,000 is around the 12.279. So what does that mean then? Let's put a little description here. The 12.28 represents the real cost of borrowing the extra 15,000, right? So if you're going from one amount up by the extra 15,000, then you got an incremental rate that you might want to consider. So the questions then would be, well, do you really need the extra 15,000? Number one, because it's costing you more than you might otherwise have thought. And then 2, well, if there's somewhere else, can you earn an equivalent risk-adjusted return on the $15,000 that is not invested in the home? In other words, if you don't need to put the $15,000 there, and you can put it somewhere else, could you get a better return? Alternatively, could you borrow the additional $15,000 elsewhere at a lower cost? So when you're then comparing and contrasting the added $15,000 and you're looking at the incremental rate, is it possible that you can borrow that $15,000 amount at something lower than that rate? So we can also then think about, well, what if, and we'll do this incremental rate using an IRR calculation as well. But before we do, let's think about a situation where we're going to say, what if we're planning to move in 8 years? So that means that it's going to kind of throw off our effective rate calculation. So we're going to say planning to move in years. I'm going to put years, and then I'm going to put 8 in my description up top. So we can use that 8 right there in cell E1 to reference to when we do our calculations. Going to make this then black and white. Up top, black and white. There we go. So what we need added information to figure this out are the ending loan balances, which we could do with a formula or just pull them from the amortization table. So I'm going to say, so ending balance for the larger loan, let's call it, is going to be equal to, so I'm looking at the end of 8 years. 8 years is going to be 8 times 12. I'm looking at 98 in terms of the period. Should be at the end of 8 years. I could see it either way. So we're looking, okay, so that means if I scroll down to this one after years 8, right there it is, and there it is. We're going to say 123,810. Is that right? Yeah, 123,810. And then we have the ending balance here. This is going to be ending balance for the smaller loan, making this a little bit larger. This is going to be equal to, scrolling left-hand side, 8 years on down. 8 years at the end of 8. This is going to be that 109,221. Enter. Underlining that, font group and underline. This is going to be the difference between the two ending loan balances. Okay, now that we have that information, we can once again use our rate function. So we could say rate function, which is now going to be equal to, so we're now, same kind of concept, but now we're saying, okay, we're going to sell this thing after 8 years. So we'll say rate brackets, the number of periods I'm going to say is the 8 up top times 12, which will give us that 96 that we got, 8 times 12, and then comma, the payment amount is going to be the difference in the payments that we calculated at the 157.52, comma, the present value, I'm going to make negative for the present value, and that's going to be the 15,000, the 15,000 on the present value, and then here's the comma, the future value now, the future value being that difference that we calculated at the 14,589, and then we'll close it up. That would be the monthly amount times 12, and so if we put our cursor back on that number group, percent, decimals, we're at the 12.4. Okay, so that rate calculation can be a little bit intimidating at times. I think it can be easier to see if we look at the cash flows and then use our internal rate of return calculation to look at it. So it might be a little bit more tedious to do, but I believe easier to kind of see and explain oftentimes. So let's say we have the IRR cash flow. This is the flowing of the cash. We're going to go font group, black and white. Let's center this one. We're going to say wrapping the text and center it. Let's start with this one here. So this is going to be the full number of periods, which will be down to 360. So 0, 1, 2. Tie my shoelace, please. 0, 1, 2. Buckle my shoe. But you don't have any buckles. Your shoe's buckleless. Buckleless. All right, we're bringing this on down to 360. 360. 30 times 12, in other words, which equals 360, and then centering it center. And then, so now we're looking at the difference that's taking place here. So we're looking at the cash flow differences between the two. The difference is going to be that 15,000, right? So if I was to take the higher loan, then I would get an inflow, an added inflow of 15,000 from the higher loan. And then what's the difference between the payments for that? We're going to have outflow differences of an increased 157.52. So notice I'm looking at this from the perspective of going from the smaller loan to the higher loan, us receiving another 15,000 and then paying another 157.52 about each time period. So we're going to double click on that, bringing that on down, but not yet. I got to make it absolute. Absolute F4 on the keyboard, $ before the W and 9, then double click on down. Then if we go all the way down to the bottom of this thing, E-ding, then we're going to say this will be the total, sum it up, little darling, sum it up. That's my Bob Marley accounting Excel stuff. So this is going to be then the IRR calculation. The rate at which this series of payments would be 0 equals the IRR or and then we'll IRR it up. Doesn't sound quite right. And then we'll close that. Make that a percent. We're going to go to the total number percent, add a couple decimals, multiply it times 12 now. Double click because that's the monthly rate times 12. There it is, the 12.84 once again has been determined, but this time with a completely different path to it. What about the IRR for this 8 years thing? If we stopped after 8 years, let's copy this. We're going to copy from the skinny column to these other columns, which aren't fat. You know, they're just not like super skinny. That one's like anorexic. These are normal columns. So I'm not trying to... Anyway, now you called it anorexic. Now that was kind of mean, but whatever. So we're going to have now, what if this happens? Then we're going to have, this is going to be 15,000 there. And then we still have these differences on down to how many payments now did we have? It was 8. What's 8 times 12 again? 8 times 96, was it? 96. Here we go. I don't do math in my head because I'm Excel. 96, that's not a 9. 96 right there. And then we could delete everything under that because we're not doing that. We're selling before that happens. So we'll delete that part and shift it on up. And then that last part, we'll have to pay off the loan balances. So really we're looking at the differences in the loan balances. So same concept here, but now we have a difference in the two loan balances, which is going to be the 14,585. So that's what we're going to be picking up down there. All right, now we're going with the sum function, total. So we get to do our little song here, equals the sum of, and then we're going up to the top, sum it up, that was not long enough for my song. All right. I'm too fast. I'm too fast for singing. Something went wrong, though. Hold on a sec. Let's try it again. Summing it up. There we go. Okay, and then we're going to take the IRR, the rate at which this series of payments would be 0 equals the IRR. And then this series of payments. Closing it up. Putting our cursor on the IRR number group, percent, adding some decimals. That's the monthly rate, double clicking on it, multiplying it times 12 for the yearly amount, 12.4. Once again, the answer has been achieved, but in a completely different fashion. I think the IRRs are kind of more intuitive, but there you go. Obviously, when you do this kind of calculation, then you do have that difference with the different time constraints will throw things off, so you have to determine how long you're going to have the loan out for. Let's do some formatting for formatting's sake. Let's make these our blue and blue and bordered. Border blue, border blue. Font group, border and blue. That's not blue, that's black. You can't see the lettering if you make it black because the letters are black. If you want to make the letters, anyways. We're going to bring this all the way down. Border blue, border blue. We're going to go font group, borders and blue. And let's do the same thing here. Border blue, and right there. So let's just do some formatting, some touching up. Let's see if I spelled anything wrong again. Spell check. Would you check that out for me, Excel? Perfect spelling. Perfect spelling. Let's make these the same size. I'm going to holding down Control. I'm selecting all these so I can have adjacent cells, non-adjacent cells, and then make them all the same size. Oh my, that's so much nicer. Looks perfect. Looks perfect. All right, let's stop it there.